What you're going to do is you're going to write it like a long division problem. Okay. Now, when you start a long division problem, you divide. Now, let me just label some stuff for you real quick. This is the divisor, right? Okay. This is the dividend. We're going to end up with a quotient and then a remainder. Okay, so that's the language that we use when we divide. All right, dividend divided by divisor is equal to the quotient plus the remainder. All right, remember that because you're going to see that in a lot of instructions and so make yourself some notes if you need to, if you don't know that, if you don't remember that from back in the day. So the first thing you do is you look at it and you say, okay, well, I can't take 7 and divide it into 1, but I can take 7, it can go into 15, and it can go in 2 times. Keep everything lined up nice and neat. That's going to be crucial when it comes to polynomials. Then you multiply. 2 times 7 is 14. You can draw a little line because now you're going to subtract to get whatever remaining from 1,500 is. So when you subtract 15, take away 14, you're going to be left with 1. Now from this point forward, you no longer divide into here. You divide into whatever you have left over after you've subtracted. If there's not enough to divide into it, if it's not big enough, you can bring down as much as you need to. So 7 doesn't go into 1, so I'm going to go ahead and bring down another 1. Now 7 does go into 11. It's going to go in 1 time. So that 1 times 7 is going to give you 7. And we're going to subtract, giving you 4. 7 doesn't go into 4, but it does go into 49. 7 goes into 49 7 times. And 7 times 7 is 49. You subtract. There's nothing left. Does anybody remember what that means when your final subtraction is nothing left? What does that mean? Is there a remainder? Is there not a remainder? No remainder, right? So you would say, if you recall, you would say remainder 0. Okay? Now, another way to write that is quotient plus remainder over divisor. So what that means is, if we had, for example, 21 divided by 5, you would say, well, 5 goes into 21 4 times with 1 remainder, correct? So you could write that as 5 goes into 1 4 times, 1 remainder, so 4 and 1/5. Does that make sense? Remember that when you were a kid? You're going to do that. You're going to do that very similarly. You're going to do that with polynomials as well. That's why I brought that up. So this is 217 plus 0 over 7. 0 divided by 7 is 0, but I'm just saying that's the way to write it if you're going to write quotient plus remainder over divisor. Okay? So far, so good? All right.
Kind of took the shortcut and just did 1,400 divided by 7 and then plus 17.
Well, yeah, I mean, exactly. And that's the way I teach long division to little kids is, well, look, do 1,400 because 7 goes into 1,400. That's 200 times. And then then you got 119 left over. We'll take 70 of that. Keep on pulling out pieces that you can divide. A little bit harder to do with polynomials, so I don't approach that. I want to kind of model the way we're going to do polynomials with it. So, but we can talk about that too. Okay, so now let's go down and let's take a look at a polynomial example. Any questions so far? Okay, so we divided, then we multiplied, then we subtracted, then we brought down if we needed to. So let's go ahead and take that x plus 6 and divide it into 2x squared plus 15x plus 20. Okay, so there are a few subtle differences. So you definitely want to take yourself a couple little notes on the side and tell me to slow down if you don't have time to do that. One difference is you're not dividing x plus 6 into the whole thing. You're just going to take the lead term, which is x, and divide it into the lead term, which is 2x squared. So it's going to be lead term into lead term. So this may be something that you want to write down, lead into lead, or something like that that'll make you remember that, because you're not going to divide x plus 6 into things at first, okay? So I'm looking at x. How many times does x go into 2x squared? So in my mind, I'm thinking 2x squared divided by x. Put them on top of each other and cancel out an x. What do you have left? 2x, right? So I can line up that 2x here because we keep the linear terms on top of the linear terms and so forth. So I divided x into 2x squared. That was my division part. We all agree? Okay. Lead term into lead term. Now comes the multiplication part. Now I'm going to multiply 2x times x. That's going to be 2x squared. And then 2x times 6 is going to be 12x. All right, see how I multiplied 2x times x? And I got 2x squared. Those should be the same because you divided them, right? If they're not the same, you did something wrong. That's like saying 6 divided by 2 is 3, 3 times 2 is 6. They should work. If not, you made a mistake, okay? But now I'm going to multiply. Although I didn't divide the x and the plus 6 as well, I am going to multiply it now. So 2x times x is 2x squared, and then 2x times 6 is going to be 12x. So far, so good? Jake?
Why is it 2x above the 15x?
Because when I add, subtract, and multiply and divide with polynomial, it helps to keep them lined up so you're combining like terms. It's a little easier to see. Yep. Doesn't necessarily have to be, but then it can get a little ugly. Okay, so I multiplied. Now what I'm going to do is, and this is where all the mistakes are made, or at least most of them, I'm going to subtract. So 2x squared, take away 2x squared, that should be 0. Now here's where kids make a mistake. If it ends up being like a negative 12, they'll forget that it's a subtraction and they'll add, or vice versa. So 15x take away 12x is 3x. So far, so good?
Wouldn't it just be 3?
No, because 15 x's and I take away 12 of them, I got 3 left, right?
Sorry.
That's okay. Okay. So, now it's time to bring down because I have to start dividing all over again. So, I can bring down my 20. Now I can go back up to the top of my list and I can divide. X, now I'm going into the bottom one, remember? Goes into 3x how many times? How many x's are in 3x? 3, right? So that's going to be a positive 3. So that takes care of my division. Now my multiplication. 3 times x plus 6. 3 times x is 3x, and 3 times 6 is 18. Everybody see where I got that 3x plus 18 from? We're good? I multiplied the 3 that I just divided, 3 times x and 3 times 6. And that gave me that. It's basically like distributing 3 times x plus 6. So far, so good? All right. So now I took care of my multiplication. It's time to subtract. 3x take away x is 0. And it should be because I divided it in, so we're just going in reverse. But 20 minus 18 is 2. Okay? I have nothing left to bring down, so I'm finished. So isn't 2 my remainder? So my remainder is 2. So how can I write that? Just like I did up here, 21 divided by 5 I put 5 into 21, and I got 4 and 1/5, because the remainder was 1. Same here. It's going to be 2x plus 3 plus the remainder over the divisor. Okay? And that form, you're going to see they're going to write on certain things like this. They'll write it as, let me put a little cloud. That's going to be quotient plus remainder over divisor. Q plus R over D. They'll say write the answer in that form. Okay, so make sure you take note of that, because a lot of kids will look at the directions and they'll say, what does that mean, Q plus R over D? Q means the quotient plus the remainder over the dividend. The divisor, excuse me. Okay? We good? So that's the process. There can be some that are a little bit more technical. We have to bring down more than one thing or here and there, but we'll get to those, and you're going to watch a flip with that on it as well to kind of finish this out. Now, there's another little way you can divide as well. If I want to divide x plus 8 by x plus 3, what do you notice about the degrees on the problem we just did versus the degrees here?
The degrees of that one are equal.
Yeah, the degrees are equal. A lot of times when you see that, you can divide using a little different method or a different strategy. And here's how it works. I know that x plus 3 goes into x plus 3, right? Because they're the same thing. So what you can do is you can split up that x plus 8 into x plus 3 plus 5 over x plus 3. Now let me digress for a second. If I were to say to you 2/7 plus 3/7, isn't that equal to 5/7? Can't I go backwards and say, okay, I got that 5 from adding 2 plus 3, so I can just think about it this way. So what I did was the two denominators came together because they were the same thing, and I got 2 plus 3 over 7. Can I go backwards? So in other words, I can write this x plus 3 plus 5 as x plus 3 over x plus 3 plus 5 over x plus 3. Ooh, can't really see that, can you? Let me just move some stuff over here. Hang on. Let me clean it up. I'm just going to rewrite this. So if you have neat notes, don't erase it. I didn't make any mistakes. I just want to make sure it fits all on this page. So I'm going to write that as x plus 3 plus 5 over x plus 3. And now what I can do is I can split it, just like I did down below with this fraction. I can say, well, that's x plus 3 over x plus 3 plus 5 over x plus 3. So just like the denominators, I brought the denominators together down here, you can also pull them apart. So I took that 2 plus 3 over 7. If you want to look at it going backwards, you can write that as 2 over 7 plus 3 over 7. That's exactly what I just did. I added in reverse, okay? So we're actually pretty much done here. Once you figure out a clever way to do that, what is x plus 3 divided by x plus 3? That's just 1 plus 5 over x plus 3. You're done. So sometimes you can use that method, and it's a heck of a lot easier than the long division. Does that make sense? A little different way to think about it. Anybody have any questions for me? All is good? Awesome. All right. So let you guys practice a couple.